Intermediate Algebra for Statistics, Multiplication of Polynomial Expressions and Functions, Part 3. Lesson Objectives: Find product functions. Use product functions to describe authentic situations. Lesson Objective: Product definition. If f and g are functions and x is in the domain of both functions, then we can form the product function f times g. So the basic idea behind this is we take one function, multiply it by another function, and we get a new function called the product function. Let's look at an example. Example 8. Let f of x equal 3x plus 7 and g of x equals 5x minus 2. Find an equation of the product function f times g. Find f times g of 2. Solution: so we're going to take the function f and multiply it by the function g. So we will take the binomial 3x plus 7 and multiply it by the binomial 5x minus 2. Using the full method, we have 15x squared minus 6x plus 35x minus 14. Combine like terms, and we have the function 15x squared plus 29x minus 14. This is a quadratic trinomial, and this is our new function. Number 2, define this function evaluated at 2. Wherever we see an x, we substitute 2. Then follow the order of operations, so we would square, then multiply by 15, then multiply, then add and subtract, and we get 104. So for this function, when the input's 2, the output is 104. Lesson objective. Example 9. The annual cost of state corrections, prisons, and related costs per person in the United States can be modeled by the function C of t equals 2.75 t plus 102, where C of t is the cost measured in dollars per person in the year that is t years since 1999. The U.S. population can be modeled by the function P of t equals 3.3 t plus 248, where P of t is the population measured in millions at t years since 1990. Number 1. Check that the data fits the data well. Number 2. Find an equation of the product function C times P. Number 3. Perform a unit analysis of the expression C of t times P of t. Number 4. Find C times P of 20. What does it mean in this situation? And lastly, number 5. Use a graphing calculator graph to determine whether the function C of P is increasing, decreasing, or neither. So solution. Number 1. Check the fit of the cost model and the population model. So this is the cost model. This is the population model, and both these lines fit the data well. Number 2, C of P of t is the cost function times the population function. So we have this binomial times this binomial. We're going to full. So by the full method, we have this 4-term polynomial. Combine like terms, and we have our new function. 9.075 t squared plus 1018.6 t plus 25,296. Number 3, unit analysis. C of t is dollars per person. Per means we divide. P of t is millions of people. So we can put this over 1. The person and the people will cancel. So our units will be expressed in millions of dollars. So it checks. Number 4. Find this function evaluated at 20. We substitute 20 in for our x. Follow the order operation, and we get 49,298. So this means that the total cost of state corrections will be $49,298 million. Now another way of expressing that is to say that's the same thing as 49.298 billion. And we get this value by taking this number, multiplying it by a million, and then changing the units to billion. And this amount will be in 2010 according to the model. Number 5, to graph this function, we enter the function in y1, then we press window, we set the x-min and x-max to be 5 and 20, and then for the y values we use zoom fit. So we put the product function in y1, we hit our windows, we change the x-min to 5, the x-max to 20, and this relates back to our data set. And then to determine the y values, we hit zoom and zoom fit. This is the product function, and we see that this is an increasing function. Hence, it's been increasing since 1995, since t is equal to 5. Thanks for watching.